All right. So when it comes to mass extinctions, my guess is a lot of you said something about like asteroids, right? Because that's what killed off the dinosaurs. Was an asteroid hit the Earth that blocked out the sun and caused a bunch of plants to die, and a whole bunch of species died. Uh, and that was true for that one, but pretty much as far as we know, all the other mass extinctions were actually not caused by asteroids. They were caused by climate change, what we call paleoclimate change. And again, this is before people, so people were not involved in this climate change. But the Earth goes through these natural cycles. Usually it's fairly gradual, especially compared to modern climate change. But there are sometimes these relatively abrupt changes where suddenly, due to various factors, the climate changes way faster. And when that happens, that is often when you get a mass extinction, is when you have conditions changing really fast, either getting hotter or colder. So why do we study paleoclimate? So, we're like, okay, so we can figure out what the climate was like over the history of the Earth, but why do we want to study that? First, we can compare it to modern climate change, what we call anthropogenic climate change. Anthropogenic just means like made by humans. So our human-based climate change, how different is it from past climate change? So by studying the past climate change, we can say, okay, is the climate change we're doing now pretty similar to that, or is it very different? It's very different. So we'll talk about that more in a later lecture. Also, we can figure out the climate sensitivity. So, for example, we're like, okay, if the carbon dioxide levels went from this to this, what level of warming does that result in? Like, how much hotter does it get when carbon dioxide levels go from this to this? So, by figuring out past conditions, which also usually involve a change in carbon dioxide, we can figure out what we can kind of expect as we go forward in modern climate change. Not only for the temperature changes, but also for sea level changes, because we can look at, as the climate changed in the past, what did sea level do? Because sea level also changes with climate change. And we can also look at the causes and effects of faster climate change. Like I said, there are times in the past where the climate has changed relatively fast. Again, nothing compared to how fast it's changing today. But from a geologic sense, it changed pretty fast. And we can look at what the effects of that were. So why does the climate change? This is probably a review, so I'm not going to spend a ton of time on this, but the greenhouse effect. This is a thing that happens where certain gases in the atmosphere allow the visible light of the sun, so like sunlight, to go through. But then when the sunlight hits the earth, it then is transformed into heat, infrared. Basically, it's transformed from visible light into infrared, which is heat. And that light is not able to pass through the greenhouse gases. So it really is very much like a greenhouse. So greenhouse is those big glass houses that you might see that people keep plants in to keep them warm. So those big glass houses, the sunlight again can go through the glass, right? Glass is transparent. But when the heat is trapped by the glass, so the sunlight goes through, turns into heat, the heat gets trapped by the glass to keep the greenhouse warm. So this is very much how the greenhouse effect works on the Earth too. Now, this is a natural process. There's pretty much always been certain levels of carbon dioxide, nitrous oxide, methane in the atmosphere, and that has changed over time, as we'll talk about. And in fact, without any greenhouse effect, we had zero greenhouse effect, the average temperature of the Earth would be 0 degrees Fahrenheit. So it would be way too cold for us if it wasn't for some level of the greenhouse effect. So what's happening now with climate change is basically like too much of a good thing, where we're now increasing the level of these greenhouse gases, which then also increases the temperature of the planet. These greenhouse gases include carbon dioxide. That's probably the one you've heard the most about, because it is the most kind of there's the most of it, and we tend to contribute the most of it. But other greenhouse gases include methane and nitrous oxide. So that's these guys here. There are a bunch of others that are in smaller amounts. And also, water vapor is actually a greenhouse gas, though we often don't talk about that as much because, first of all, it's highly variable. It goes up and down like a lot, just even like over the course of a day. Water vapor can like go up and down, and its effect on the climate is a little more complex. So we do factor into like climate models, but we don't often talk about it in terms of like causing climate change. Yeah, it's more of anyway, it's a little complex. Um, so any process that changes the amount of these gases in the atmosphere will cause climate change. So course, like what's happening right now, if you increase carbon dioxide, it'll get warmer. But if you decrease carbon dioxide, it'll get colder. So again, changing the amount of these gases in the atmosphere will change the climate. And there's a few different processes that can cause climate change. So this is, of course, other than humans. So in the past, in paleoclimate, these are some of the things that caused climate change. First, energy from the sun. So the sun's energy has slightly changed over time, but the bigger effect on how much of the sun's energy is hitting the earth are what we call Milankovitch cycles. You don't need to know this, but I'm going to talk about it a little bit because I think it's really cool. So they're over the course of thousands of years, tens of thousands of years, the Earth, there are small changes to how the Earth orbits the sun. And that changes how much energy we are getting from the sun. So, for example, one of them is eccentricity. This is how oval is the orbit of the Earth. So, if it, try to see it, show this. The sun's right here, the Earth kind of goes around it in an oval, right? And that oval can be a kind of thinner or it can be kind of closer to a circle. And that is eccentricity, is how that changes over. And this is a cycle that happens on roughly 100,000 years. But there's also things that have to do with basically the tilt of the Earth's axis as well. Those are obliquity and precession. Another thing that will drive climate change are volcanic eruptions. Volcanic eruptions put more greenhouse gases into the atmosphere. So there have been times in the past where there's more geologic activity that meant more volcanic eruptions, and that increased the greenhouse gases and caused climate change. Photosynthesis can also affect climate change because photosynthesis sucks up carbon dioxide. So it decreases the carbon dioxide in the atmosphere. And in fact, when photosynthesis first evolved, it caused this like massive global cooling that almost wiped out life on Earth. That was called the oxidation event. And then plate tectonics also can cause climate change as well. So these are all things that have caused climate change on the Earth in the past. So what does this climate change look like? We generally refer to it as glacials and interglacials. So glacials sounds like glacier, right? So you can guess glacials is when it's cold. So those are the colder time periods on Earth. And interglacials, that is the time between glacials, right? Interglacial, between glacials. That is the time when it's warmer. So the Earth's, it's not like a super even cycle. Like it's not, exactly every 10,000 years it swaps, but it generally kind of goes up and down between these glacials and interglacials. And this is kind of showing that over time. This is based on sea surface temperature, so the temperature of the ocean. Like you can see, this is a pretty long glacial period, but in general, the temperature of the ocean kind of goes up and down between the glacials and interglacials. And this is on the scale of tens of thousands of years. So let's now relate this to sea level. So I believe this is our last question for today. Would you expect sea level, so how high the ocean water is, to be higher during a glacial or an interglacial? So think about where the water is, because there is kind of the water cycles, but there's basically a more or less finite amount of water on the planet. So where it's located will affect what the sea level is. So think about that and try and figure out, would you expect sea level to be higher during a glacial or interglacial time period?